Okay, let's dive right into this. We're always talking about how powerful AI is getting, but there's this one huge question that we often just gloss over. And it's this question right here. When a model spits out a prediction and says, hey, I'm 99% sure about this, it feels really reassuring, doesn't it? But what if that confidence is just an illusion? What if the model is just incredibly confident about being wrong? See, this is the crucial difference we need to wrap our heads around. On one hand, you've got confidence. That's just what the model thinks it knows. It's an internal feeling. But then you have accuracy, and that's all about what actually happens in the real world. The whole goal is to get those two to line up, because when there's a gap between them, well, that's where the trouble starts. And this gets to the heart of the problem, this potentially dangerous gap between an AI's proclaimed confidence and actual reality. You know, there's a name for this. It's called poor calibration. The best way to think about it is like a weather app that predicts a 90% chance of sunshine every single day. Now, on the days it's sunny, the app looks like a genius. But when it pours rain, it was still 90% sure it was going to be sunny. That kind of confidence isn't just unhelpful, it's downright misleading. And that's exactly the problem we need to solve. So the big question is, how do we fix it? How do we get an AI's confidence score to actually mean what it says? Well, luckily there are tools for the job, and the whole process is known as calibration. The main tool in the toolbox is something called post hoc calibration. Now, don't let the fancy name fool you. All it means is that it's a fix you apply after you've already trained your main AI model. Think of it like taking a super powerful car engine that you've just built and bringing it to a specialist for a final tune-up. You're just making sure its performance is smooth and reliable. So, how does this all work in practice? Well, it's actually a pretty straightforward three-step process. First, you train your big, powerful AI model. Step 2, you let it make its initial raw predictions, the ones that might be a little overconfident. And then, for step 3, you pass those predictions through a special calibration method to fine-tune them and make them more realistic. Now, here's where it gets really interesting. There isn't just one way to do this. For a long time, a couple of methods have been the undisputed champions, the go-to choices. But a major study recently decided to pit these old guards against some newer contenders. So they lined up 5 of them: the classics, isotonic regression and Platt scaling, and some newer challengers, beta calibration, Vene-Belubar's predictors, and another one called Pearsonify. And this wasn't just another small-time experiment. No, researchers went all out. They designed a massive study to see which of these methods actually holds up in the real world, especially when you use them on the kinds of powerful AI models we have today. They basically set up a huge bake-off. The study was all about taking a hard, evidence-based look at the problem. No more just assuming the old methods work. They wanted to see with cold, hard data what really happens when you apply these calibration tune-ups to a whole range of modern AI systems. And when I say a whole range, I mean it. They tested everything on 21 different types of AI models. These are often called classifiers. They're what an AI uses to make a choice, like, is this email spam or not? And the test included everything from the old-school classic models all the way up to the powerful neural networks that are state-of-the-art today. So you've got 21 different AI models, and against each of them, they unleashed our 5 competing calibration methods. It was a true battle royale to see which one could consistently make an AI's confidence actually trustworthy. The goal here was crystal clear. Find out which methods are genuinely helping our models, and just as important, find out which ones might actually be making things worse. Are the old, trusted methods still the champions, or could they be secretly hurting the performance of our best new AI? And the findings, well, they were pretty surprising. In fact, they're absolutely crucial for anyone building or using AI today, because the results pretty much flip years of common practice on its head. So here it is, a direct quote from the paper, because it's a bombshell. The most commonly used methods, plot scaling and isotonic regression, the ones that are often the default choice, can actually make modern AI models worse. Think about that. The supposed fix was actually breaking the machine. And the data makes this so obvious. This chart here shows the average impact each method had. You can see Van Abers and beta calibration way up there, providing a clear positive boost. But then look down at Platt scaling. Yikes, its effect is tiny and sometimes even negative. It got consistently beaten. So let's just spell it out. The new champions, without a doubt, are Van Abers and beta calibration. They proved to be both powerful and reliable. Van Abers gave the biggest average improvement, while beta calibration was the most consistent performer. Meanwhile, the old standards, Platt scaling and isotonic regression, weren't just weaker, they were inconsistent and could actually damage the performance of the very models they were supposed to be helping.
Okay, so what does all of this actually mean? Well, it means the rulebook for how to build AI you can actually trust just got a major update. Here are the key takeaways. Number one, the old defaults are broken. If you're using a powerful, modern AI, something like Platt scaling should no longer be your automatic choice. In fact, it could be a liability. The research is clear. Then Abers and beta calibration are the new top performers. Choosing the right one is absolutely critical. And look, this isn't just some abstract academic debate. This stuff really, really matters. If an AI is helping a doctor diagnose a disease or a bank spot financial fraud, a 99% confidence score has to actually mean something. In those high-stakes situations, misplaced confidence can have devastating consequences. Proper calibration is what turns a powerful AI into a trustworthy one. Ultimately, what this all pushes us to do is think beyond just making AI more powerful. It forces us to ask, how do we make it more honest? Honest about what it knows and what it doesn't. And as these systems get woven deeper into our daily lives, that honesty, well, it might just be the most important feature of all.